All right, guys, welcome back. So now we are going to move on to lesson 6.3. And we've learned our if statements. We've learned our if, elif, else chains, how we put items in. But now what we're going to do is we're going to learn how to process multiple things at the same time. So let's just dive into a really quick example. We're going to actually ask in this program, we're going to take our password program that we used last time, like if password equals ABC123, but now we're going to make a username and a password. And so what we're going to do is username equals input, username prompt, password equals input, password prompt. Okay. Now, we have two of them, so it's going to be a little difficult to make sure that both of these work. One thing that we could do, and this is not what we're going to learn today, but this is just showing you the old or traditional way before we've learned this skill. If username equals Brian, then we could do if password, not if I password, if password equals ABC123, print success. Now this could work because we check to see if it's password and only, check to see if the username is correct, not the password, I'm thinking of the wrong thing. If username is Brian, inside of that we're going to say if the password is ABC123, we'll print success. This could work, but it doesn't work great. What I would like to do instead is just have one thing that's checking for it. All right, let me just bring this back one. There we go. So if username is Brian, we have success. I'm not done on my requirements. What I'm also going to say is and this is the first thing that we're learning today, password equals ABC123. All right, so now I can require two things. If the username variable is Brian, and meaning that this other thing must also happen, the password is ABC123, I will print success. So let me try running this. Okay, it's going to ask me for my username. I'm going to put it in correctly. Password, ABC123, put it in correctly. I get success. Let's add an additional thing, else print incorrect. Okay, so now if I run it again, we can see like a failure work with this. So let's try that. All right, username, let's do the correct username. Password, I'm going to put something different, XYZ987. I got incorrect because it required both of these things to happen. Same thing if I put in Bob as a username and the correct password, still doesn't work. And even if I do something that is entirely wrong, that also gives us incorrect. So the and requirement allowed us to require two separate things to happen. It's saying you must do both of these things. We can get more specific. We could add another and we could keep going and going and going if we wanted to. There's really no limit. So it's kind of something interesting that you can take a look at and play around with. And yeah, so that's the first one. The and is part of this thing called Boolean Logic. All right. Boole was the person who created this. They basically tried to figure out a way to connect language, like English language, and combine it into mathematical logic. And it was a really, really valuable thing because you all of a sudden start to realize that, hey, even in our own spoken language, there are some mathematical aspects. For example, using the word and to connect. So that's where we get the phrase Boolean logic. All right. So that's the first one with and statements. Let's nuke this, and we can look at our results at the bottom. That's fine. All right, so now what I want to do is I would like to make a code that uses the other thing we're going to learn, which is or. Or is more flexible. We can do either of them. So I'm going to say capital NY equals input. What is the capital of New York? If capital New York equals Albany, we'll print correct. This might look familiar. Else print incorrect. Okay, so that's the base program. Let's just test it to make sure it works, and then we're going to add an OR statement to enhance our code. What is the capital? It's not Albany, it's Albany. And I get correct. Okay, cool. And if I type something wrong, Middletown, I get an incorrect. We've done this before. We've made better programs because we have more if statements that accept Albany as a lowercase or all caps. But what if I wanted to put that idea in here? Or capital NY equals Albany. If I could spell it right, that would be nice. Okay, so now if I run this, it will also accept Albany as lowercase. Or if I run it again, it still accepts uppercase. And in this case, though, this is the only one, the caps lock version, where we get an incorrect. So why don't we add another statement here? Or capital NY equals Albany. So now we have the three different types of things that a person could type in. If capital New York equals Albany, or capital New York equals Albany lowercase, or capital N New York equals Albany in uppercase. Now, there are some things that I want to go over. The biggest thing is a lot of people will forget to put in the actual variable being equal to. So for example, if capital NY equals Albany, that doesn't work. And we can actually test that, right? So let's say I type in the correct one. Yeah, we get correct. Okay, let's say I type in anything. That's not the capital of New York. SDGHWELRBGE4 is not the capital of New York. So what's happening is Python is looking at this. When we say if, we're basically saying, hey, Python, set this up for a true or false. And let me just get rid of these guys. Let's do kind of like a foundations lesson really quick. All right, if capital New York equals Albany, what we're basically doing is we're setting a truth table right here. And it can either be a 1 or a 0. 1 being true, 0 being false. So if capital NY equals Albany, that will evaluate to a 1. Because we have the item being tested to be equal to capital ALBANY. All right? So that's what it does. If it's not, it evaluates to a 0, and that's how the else knows to pick up from this. But now let's go back to this example. Here's where we have a tricky or interesting situation. Capital NY equals Albany, that can evaluate to a 1 or a 0, right? Because we have a test to see if the variable is equal to Albany. If I just say Albany, that's the equivalent of saying if Albany. If what is Albany? And that's where Python is starting to get a little bit confused on here. All right, I could probably run this and this would probably work. It doesn't matter what I type in the input because capital NY has nothing to do with this if statement anymore. And it just evaluates to correct because if Albany, it literally takes Albany, ALBANY, and plugs it through a logic system and either determines a 0 or a 1. So in this case, ALBANY evaluates to a 1. And so if 1, we print correct, and then this else gets shut down. Weird how code does that. So basically what I'm trying to say is, when you're writing code, you may just very sloppily like, oops, I typed in something that was not supposed to be correct, and I can't find the issue. If you use an OR statement, always check for something like this. All right, if capital New York equals Albany, or Albany, this is wrong. This is not good, and it's not going to give you effective code. Because remember, we need precise control over every tiny aspect of our code when we run it. All right, so you want to make sure that if you say if the variable name is Albany, or the variable name is Albany, or the variable name is Albany, you have to make sure that you are addressing those things. Now, there are other ways to do it by making a group of data and checking for all the possible cases in there. Maybe that's something we'll look at later. But for now, again, introductory programming. We're learning the basics, the building blocks. stick to this kind of method. So if capital NY equals Albany, or capital NY equals Albany, you get it, okay? So that is kind of the and or statement. So the and allows us to add additional requirements. The or allows us to kind of like expand of what we will accept. It's like, hey, I'll take all these things, I don't care, and only one of them has to be true. Now the big question is, can we combine them? Yes, we can. There is a little bit of a kind of like a caution that we need to take. So let's make something really quick. Username equals input username. We're going to go back to that old thing. Password equals input password. And I'll make it look nice like that. All right. So username is, we ask for the 2. If username equals Brian and password equals ABC123, print success, else print login denied. Okay, so yeah, we saw this before. But what if I wanted to add more things? Maybe I want to add another user to this. So could I say, or username equals Adam and password equals XYZ987. Okay, so now, I mean, you look at this, you can follow the logic. If the username is Brian and the password is ABC123, or the username is Adam and the password is XYZ987. So we should be able to just like give this a try. So let's give it a try. Okay. Let's see. We can plug in or sign in Brian, ABC123. Cool. That works. Okay. Adam, XYZ987. We get success as well. Neat. All right. Let's try Brian and password is XYZ987. Login denied. Okay, that's good. All right. Adam, ABC123. Login denied. So that's good. All right. So this seems to be working well. Now, what I want to urge you to be cautious about is if you look at the way that this code works, ands and ors are kind of like multiplying and adding. Okay. So this seems to work nice like this. However, what I am going to suggest and very, very urgently stress to you is make sure that you use parentheses to force certain things. All right. So for example, I'm going to throw parentheses around this. All right. If username is Brian and password is ABC123, or the username is Adam and the password is XYZ987. The reason that I want to do this is because I want to force these things to happen, or I want to force these things to happen. Sometimes in code, your stuff may kind of goof up the ordering if you do certain types of like adding or, you know, like throwing things together of that nature. You know, just like adding and multiplying, if you goof it up or you put it in a bad order, it could give you some major issues with it. All right. So for this is more of just an exercise in making sure that things work properly by forcing parentheses by saying, look at these two, or look at these two. This example doesn't exactly show that, but use your parentheses and trust me on this, because if you don't follow that method, one day you're going to have this little like goof up or this little slip up and you're going to be like, what happened? I wrote the code perfectly according exactly to what he said and it still doesn't work. Use the parentheses to like sort out your ideas. All right. Because in the assignment that we're going to be looking at for this, we're going to need these if we want to add some extra functionality to our code. All right. So what we're going to be building, and this is a pretty neat thing. This is one of my favorite projects in Python. We're going to be building rock, paper, scissors. All right. What you're going to be doing with this is you are going to be asking both players, player 1 and player 2. So player 1, enter your move. They type in rock, paper, or scissors. Then player 2, enter your move. Yes, they can see each other's motions or like actions or things like that. If you can figure out a way around that, Nice. Let me know. Post it in the comments if you figured out a way to make it so that you can't see what the other user typed in. One way to do it, a bunch of print statements with nothing in it. So player 1, and then print. So like the player 1's move moves all the way up off the screen, and then player 2 gets prompted to enter in their move. So they can see how that works out. But anyway, we're building rock, paper, scissors, all right? And you're going to have scenarios where, like, so let's ask each player for input. All right, these are going to be strings, no mathematics, no numbers, no integers, no floats, just regular old input like I have up here. So this is kind of like a nice transition example. Ask each player for their input. Then you want to determine all the possible moves. So determine all possible moves, and that is things like P1 rock, P2 scissors, and that should point to P1 wins. All right, you're going to do that with every single type of move. P1 scissors, P2 paper. All right, and that's going to give you, again, P1 wins. So you're going to have all these scenarios. Now, if each player has 3 different moves, and there are 2 players, what it's going to imply or tell us that we need to do is 3 to the power 2, right? Because it's rock, paper, scissors for player 1, rock, paper, scissors, those 3 for the first rock, rock, paper, scissors for paper, rock, paper, scissors for scissors, and you're going to have all these different moves. So you're going to have 9 total checks, and these are going to be if and elif statements. You should also have an else statement at the end. You need to figure out what this does. All right, like why do we need an else statement? I'm looking forward to seeing like what you give as an else statement if none of the rock versus paper versus scissors combinations were hit. All right, and then we also have some bonuses. All right, so these will just use and statements unless you want to add some bonus achievements to this. And in my coding class, you are required to do some of this stuff if you want to actually move your grade up to a 100. So the first thing is accept more than one type of input. And what I mean by that is they can type in rock, capital rock, basically any of these that is a type of move, all right? You don't have to do all of them, but you just need to accept more than one. So you can even say at the top, player 1, enter your move, type rock, comma, or just the first letter, something like that so that they know that they can type in capital R, or lowercase r, all lowercase word rock, proper case, full capital, whatever you want to do. You just need to accept it. There's many ways for it to be accepted as code, all right? What you can also do is punish a player for making an incorrect move. And that's going to be something in the else statement that runs. This is going to be something that's very interesting because that's a very tricky piece. And the only hint that I'm going to give you for that bonus is if one of the players make a mistake, that else statement is probably going to be activated, right? So once you've done that, you've established at least one player has made some sort of mistake. Inside of that else scenario, instead of trying to figure out which player typed in the wrong move, what if you figured out the player who typed in the right move? That way, if player 1 didn't do anything wrong, they entered any sort of acceptable move, then we know that player 2 loses. And this is a very, very interesting approach, to getting this going on. This is the kind of thing that if you want to really think like a programmer and try to figure out solutions, this is something that you want to take a look at, all right? So that's pretty much it for the and or statements, Boolean logic in a nutshell. There are also other types of Boolean logics that you can use, like the word not. We're not going to go into that in the intro course, but not is basically the opposite of something. So you could say like if not password equals ABC123, and it basically does the inverse or the opposite of it. So if as long as it's not true that the password is ABC123, we're good. All right, so that's something that you can also play around with. I wouldn't do it in this rock, paper, scissors example unless you're done and you want to just kind of play with some extra stuff. But yeah, we're starting to enter territory where you really want to start inventing your own challenges, inventing your own things to play around with, trying new things, getting new weird random stuff up and running. Try all these different things and see exactly what you get from it. All right? So with that in mind, I'll leave you to it. Good luck making your rock, paper, scissors game. And yeah, have some fun with it, because this is one of the first games that we actually really play and have emerging as a game. Later on in this course, we're going to learn to do something called looping, where we can have our code repeat again and again. And we're going to revisit this rock, paper, scissors game. So once you make your bare bones generic rock, paper, scissors game, make sure you save it as a copy. Call it rock, paper, scissors, basic version. That way, so you have it. You're going to need it later on in the course. If you decide to add any extra features, make a new copy so you have the old stuff. And also, if you goof something up on your new thing, at least you have your old one to revert back to get it up and running. All right? So, best of luck, and I hope you enjoyed this little lesson. And if you have any questions, post them in the comments section. Thanks for watching.